Okay, the topic of today's lesson is antibiotic resistance. I want you to take notes from this video for the first half, and then I'd like you just to watch the second half, and I will tell you when you should stop copying and just watch the rest. Antibiotics are medicines that are used to kill bacteria. Antibiotics do not work on viruses, so don't go to your doctor if you have the common cold to request antibiotics, because those antibiotics cannot kill your common cold virus, and therefore they can't make you feel any better. The very first antibiotic ever discovered was penicillin, which is probably the most famous even today. Penicillin was isolated in 1928 by Alexander Fleming. Now, the trouble for Fleming was that he wasn't a very good communicator, and he wasn't a very good public speaker. And he had a very difficult time convincing chemists of the importance, the significance of his discovery. And so that was sort of the end of the story for another 10 or 12 years. Which is unfortunate because in the intervening time, the Second World War broke out. When the Second World War started, there were no antibiotics in existence. Penicillin was known, but existed in test tubes and on petri dishes, and it wasn't a medicine yet. So when the Second World War started in 1939, men who were injured died of infections that got into their injuries. Those injuries today would have been very, very survivable. But back in 1939, because there was no antibiotic yet, men died of those infections. Now, by 1940, penicillin was mass-produced for the very first time by a man named Howard Florey. He was working at Oxford University in the UK, but he was originally from Adelaide, which makes penicillin in some ways an Australian invention. Antibiotics are widely used today. Penicillin is one of the most widely prescribed of all of the antibiotics, but there are dozens of them now. One of the problems with antibiotics is just how common they are and how often we do prescribe them. The overuse and the inappropriate use of antibiotics, including penicillin, is leading to an evolution of bacteria that are resistant to antibiotics. Now, antibiotic resistance is when a bacteria that used to be killed by a drug isn't affected by that drug anymore. Now, this is the end of the portion of the video that I need you to copy down. The rest of the video you can just watch. The rest of this video will try to illustrate to you how antibiotic resistance occurs. In any natural population of bacteria, there are some bacteria that are strong and some that are weaker. The little monsters on this screen are trying to show you the difference in a population of bacteria. So all the little monsters are bacteria. The green smiley face ones are quite weak. The neutral faced ones with the yellow halo around them are stronger. And the little monsters with the fangs and the spiky orange halo, those are really strong bacteria. As you can see, there aren't very many strong bacteria in this population. Most of the population is weak, but a very small number of them just happen to be unusually strong, and that just happens in nature. If you start taking an antibiotic, there's your antibiotic flooding the population of bacteria. The weak bacteria will die first. If you keep taking the antibiotic, say you take another dose, more bacteria die, but always the weakest ones first. eventually only the strong bacteria are left. If you stop taking the antibiotic now because you're feeling better, you used to have that very large population of bacteria that we saw in that slide, and it was making you feel ill. But now most of them have died, and the couple that remain, although they are very strong, for the moment they're so few and far between that you feel better. So that's why you stop taking your medicine. The strong resistant bacteria, however, reproduce, and you start to feel sick again. Only now there are lots of resistant bacteria that antibiotics can't kill. And that's how antibiotic resistance occurs. This new population of bacteria is a resistant population, and we will need to find a different chemical that these bacteria, these really strong ones, are vulnerable to. Otherwise, we will be left with no medicine with which to cure this disease. The last thing that I would like you to do tonight before you come to class tomorrow is to complete the comic strip that I've given you by filling in the gaps and drawing pictures for each stage to show that you understand how antibiotic resistance develops. The little cartoon with the smiley face and fang face monsters will give you some ideas and help you to complete this task. Thank you very much, Year 9. See you in class tomorrow.